Portfolio diversification of risk. An individual security adds less than its total risk to the risk of a portfolio. When we add a security to a portfolio, some of its risk is diversified away, and it adds its residual risk to the portfolio. Diversification causes some risk to disappear because the returns of risky assets are imperfectly correlated. They do not move exactly alike. It's the property of correlation that results in diversification of risk. So let's examine the relationship between portfolio variance and the correlation of the portfolio's securities. We begin with the covariance and correlation between two securities given their state contingent returns. Given two securities, A and B, correlation is the expected product of the paired deviations from expectations for securities A and B. To measure correlation, in each state, we calculate the deviation of A's state contingent return from A's expected return, and the deviation of B's state contingent return from B's expected return. We multiply the two paired deviations from expectations and multiply that by the probability of the state, and then sum across all states to get the covariance. Correlation standardizes covariance by dividing it by the standard deviation of the two securities. Let's look at an example. Given the probability distributions of A and B, we calculate their expected returns and standard deviations. In each state, we subtract each security's expected return from its state contingent return to get its deviation from the expected return. For security A, its deviation from expectation is its 60% state contingent return minus its 32% expected return, or 28%. For security B, its state contingent return is 15%, its expected return is 15%. 30% minus 15% gives a deviation from expectation of 15%. We multiply the paired deviations from expectations and multiply that by the probability of the state. We do that for all states. We sum across all states by adding up the last column. Covariance is 75% squared. To get the correlation coefficient, we divide the covariance by the standard deviations of the two securities and get a correlation coefficient of 0.47. Previously, we calculated the portfolio variance using state contingent returns. Now we'll recalculate portfolio variance using a method that explicitly considers a correlation between the securities in the portfolio. This method involves constructing a covariance matrix. For a two-asset portfolio, we construct a 2x2 matrix. For a three-asset portfolio, we construct a 3x3 matrix. For an n-asset portfolio, we construct an n-by-n matrix. In this example, we'll construct a two-asset covariance matrix, given security 1 and security 2. Each cell is the convergence of two securities. The cells contain the product of the portfolio weights for each security and the covariance between the securities. Let's fill the cells with the elements for the variance. The upper left cell, we have the proportion invested in security 1 times the proportion invested in security 1, and that's the proportion invested in security 1 squared, times the covariance of security 1 with itself, and that's the variance of security 1. In the lower left cell, we had the proportion invested in security 1, the proportion invested in security 2, times the covariance between 1 and 2. In the upper right cell, the proportion invested in 1 times the proportion invested in 2, times the covariance between 1 and 2. The lower right cell, the proportion invested in 2 times the proportion invested in 2, and that's the proportion invested in 2 squared, times the covariance of 2 with itself, and that's the variance of 2. In the covariance matrix, the diagonal elements are variance elements. The off-diagonal elements are covariance elements, and they're mirror images. The covariance elements come in pairs. The variance of the portfolio is the sum of the elements of the matrix. We sum the variance elements. The covariance elements are multiplied by 2 because there's 2 of them. They come in pairs. So we have a basic model for the variance of a 2-asset portfolio. This is an important point. Look at the model. There are 3 things that determine the variance of a portfolio: the proportion of the portfolio invested in each security, the variances of the securities, and the covariances among the securities. Let's further refine the equation. Recall the correlation coefficient is equal to the covariance divided by the standard deviations of the 2 securities. Solve for the covariance. The covariance is equal to the product of the standard deviations times the correlation coefficient. Let's substitute this expression for covariance in the model. And now the model explicitly considers correlation. I like this formulation of the model because I find correlation more intuitive than covariance. Given our values for securities A and B from our previous examples, we can use the model to solve for the variance of the portfolio consisting of A and B. The variance is 161.8. The standard deviation is 12.7%. These are the same values we calculated previously using state contingent returns. Given our calculation for the variance of the portfolio consisting of security A and security B, we're going to change the value of the correlation coefficient while keeping everything else constant, and observe the resulting change in portfolio risk. We vary the coefficient between positive 1, perfect positive correlation, and negative 1, perfect negative correlation. Observe what happens to the portfolio's standard deviations as we lower the correlation coefficient. Standard deviation declines. The important point: diversification is related to correlation. The returns of risky securities tend to be positively correlated because of the dependence of returns on general economic conditions. But the return of 2 risky securities are never perfectly correlated. The average correlation between stocks traded on the New York Stock Exchange is roughly between 0.5 and 0.6. It's the property of imperfect correlation that enables diversification to lower risk. The lower the correlation between the 2 securities, the more effective is diversification. Another aspect of diversification of risk is the degree of diversification. The risk of a portfolio is decreased by diversifying across imperfectly correlated securities. As more securities are added to the portfolio, diversification increases. But is there a limit to how much risk can be diversified away? This graph shows a reduction in portfolio standard deviation as randomly selected securities are added to the portfolio. Initially, adding securities to the portfolio results in a large decrease in risk. But there are rapidly diminishing returns. As more securities are added to the portfolio, the marginal decrease in standard deviation from adding an additional security gets smaller and smaller, until a point is reached where there's no further reduction in risk from adding additional securities. This point is reached with as few as 12 randomly selected securities. This implies that there are two types of risk: that risk that can be diversified away and that risk that can't be diversified away. The first type of risk is diversifiable risk, also called unsystematic risk. This risk is from risk factors affecting only a specific firm, and therefore is unique to the firm. This is also called firm-specific risk and unique risk. So unsystematic risk stems from events whose impact are limited to a firm or to a small group of firms, say within an industry. These include such things as lawsuits, strikes, winning and losing major contracts. Since the events are essentially random, their impact on a portfolio can be eliminated through diversification. Bad news in one firm can be offset by good news in another. The other type of risk is non-diversifiable systematic risk. These are risks associated with economy-wide factors that affect all firms systematically in the same way to a greater or lesser extent. Such things as recessions, wars, political change, price instability. Non-diversifiable systematic risk is also called market risk. So total risk is comprised of systematic risk and unsystematic risk. So after all unsystematic unique risk is diversified away, the remaining residual risk in a portfolio is systematic market risk. A well-diversified portfolio is a portfolio in which unsystematic risk is substantially diversified away, and the predominant risk is non-diversifiable systematic market risk. All rational investors hold portfolios. All rational investors hold well-diversified portfolios. Why hold on systematic risk when you can effortlessly diversify it away? So all rational investors hold well-diversified portfolios. Consider the variance of a well-diversified portfolio. A well-diversified portfolio contains n total securities. Its variance is the sum of the elements of an n by n covariance matrix. In an n by n matrix, there are n squared total elements. The diagonal elements are variance elements, and there are n total variance elements. The off-diagonal elements are covariance elements. There are n squared total elements. There are n variance elements. So there are n squared minus n covariance elements. The variance of a portfolio is the sum of the elements of the covariance matrix. Each security contributes its variance, multiplied by its portfolio weight squared, where its portfolio weight is the proportion of the portfolio invested in the security. There are n total variance elements. Each security also contributes its covariances with the other securities in the portfolio, multiplied by the portfolio weights of the paired securities. There are n squared minus n total covariance elements. So total portfolio risk measured by variance has two component parts: the contribution of variance elements and the contribution of covariance elements. The contribution of the variance elements is diversifiable risk. The contribution of the covariance elements is non-diversifiable risk, and we'll demonstrate that. But first we need to make some simplifying assumptions. Let's assume all securities possess the same variance, which we'll represent as the average variance. All pairs of securities possess the same covariance, which we represent as the average covariance. All securities are held in the same proportion in an equally weighted portfolio, where the proportion is 1 over n. So each security has a portfolio weight of 1 over n. Given our equation for the variance of a portfolio, each security contributes its variance multiplied by its portfolio weight squared. So that's average variance times 1 over n squared. And there are n total variance elements. Each security contributes its covariances with the other securities in the portfolio, multiplied by the portfolio weights of the paired securities. That's average covariance times 1 over n times 1 over n, and that's 1 over n squared. There are n squared minus n total covariance elements. This equation simplifies to this expression. The variance of a portfolio is equal to 1 over n times the average variance plus 1 minus 1 over n times the average covariance. Let's increase diversification by increasing n, the number of securities in the portfolio. As n increases, this fraction is getting smaller and smaller, and the contribution of the variance elements is also getting smaller. At the limit where n is equal to infinity, the fraction is 0, and the contribution of the variance elements goes to 0. As n increases, 1 over n gets smaller, and the multiplying fraction gets larger, and the contribution of the covariances increases. At the limit where n is equal to infinity, the multiplying fraction becomes 1, and the contribution of the covariance elements is equal to the average covariance. So the variance of a well-diversified portfolio is equal to the average covariances of the securities in the portfolio. All the diversifiable risk is diversified away, and the risk of the portfolio consists of non-diversifiable systematic risk. What does an individual security bring to the risk of a well-diversified portfolio? It brings its covariance with the other securities to the portfolio. It brings its systematic risk. A well-diversified investor is concerned with the risk of his well-diversified portfolio. The appropriate measure of the risk of that portfolio is the variance of the portfolio. An individual security is looked upon as a candidate for entry into a well-diversified portfolio. A well-diversified investor asks, what does this security bring to the risk of my well-diversified portfolio? It brings its covariance, its systematic risk. What is the appropriate measure of risk of an individual security for a well-diversified portfolio? The security's covariance, not its variance, total risk, but its covariance, its systematic risk. The important point: for well-diversified investors, the relevant measure of risk for an individual security is the security's covariance with all the other securities in the portfolio. Summarize our important points. All rational investors hold well-diversified portfolios. Individual securities are looked upon as merely candidates for entry into well-diversified portfolios. What does a security bring to a well-diversified portfolio? It brings its expected return and its systematic market risk. The systematic risk principle. Because unsystematic risk can be freely eliminated by diversification, the market will pay a risk premium only for bearing systematic risk. Total risk is comprised of systematic risk and unsystematic risk. The market won't pay you for holding risk you need not hold. So the market won't pay you for holding unsystematic risk because you can effortlessly get rid of it just by diversifying your portfolio. The market will pay you for holding risk that you must hold. You can't get rid of systematic risk, so the market will pay you for holding systematic risk. The market prices risk. The risk the market prices is systematic market risk. Because the market prices systematic market risk, the expected return on an asset depends only on that asset's systematic market risk. Our model for the expected return on a risky asset was equal to the risk-free rate plus a market risk premium. That market risk premium is a systematic market risk premium. Remember, we had to answer 3 questions. What is the relevant risk in a risky investment? The relevant risk is systematic market risk. How do we measure this risk? It's measured by covariance. How does the market price this risk? That's the topic of the next lecture.